Okay, so the live streaming for the session today has been started. I have also added the YouTube streaming link in the respective calendar event. I think someone has raised a hand. Yes, please go ahead. Sheikh Suleiman.
Sir, I have an inquiry
Uh,
that I qualified in second attempt. So what are the options available for me? I didn't get all ticket till now.
uh, to be honest, I'm really sorry about this, but I won't be able to assist you with this query. Uh, okay, so in case you have any operational related queries, I would suggest you to either reach out to the support team for the program, or maybe you can just raise a thread on the discussion forum. Maybe the people who keep knowledge for this particular thing would be able to help you there.
Okay.
Yeah, I would be able to help you with the technical queries in today's session. I am probably not aware with all other operational aspects of the program.
Okay. Thanks.
Okay. All right, so let us get started. Uh, I will start sharing my screen, so please let me know as and when my screen becomes visible to you all. I'm hoping that my screen is visible to everyone by now.
Yes, sir. It
Yes,
is.
sir.
Thank you. So today, as I said, we will be going over the important concepts that have been covered as part of the weeks 7, 8, and 9. So let me quickly write down the crux of what we will be going over in today's session with respect to the week. I mean, I will align the concepts week wise that we'll be going over in the today's session. So we shall start with week 7. Okay. Okay. So week 7 is about arrays, strings, and a little bit about pointer arithmetic. So it is going to be arrays and strings, which are actually subcomponent of the array itself, and then a little bit of pointer arithmetic. The pointers have already been introduced in week 6, but here we will be seeing that how do we use pointers with the arrays. In week 8, there are some additional user-defined data structures that were introduced, and they were mainly 3. One was struct, or you can say structures. One was union, and one was inner. Each of them have their own significance, and uh, they are used for different purposes. But yes, all of them are actually user-defined data structures that one can use while writing C programs. In addition to that, there is one more keyword that you might have heard about in this week, which is typedef, which is actually a keyword that you can use in order to create a new data type. Well, we will talk about that when we'll be doing these things. And week 9 is going to be about dynamic memory allocation. Dynamic memory allocation. So there will be a total of 3 or 4 functions that we'll be talking about. One is going to be malloc. One is going to be malloc. One is going to be calloc. Realloc is something that is probably not discussed in the course, but it's good to know for you what it is, how it works. And one is going to be free. So I guess we have already talked about all of these concepts in the previous session, but today I would like to give you a revision of what all things we discussed, in those particular sessions. I guess arrays, structures, etc., etc. These things, yeah. Okay. Anyways, so we shall be starting with the week 7 onwards. So we will first start with the concept of arrays. What are arrays? Why do we need them? And how do we implement them? So I would clear the screen. So the first thing is going to be arrays. Now, if I talk about the very basic definition of arrays, how would you define an array in C programming is, it is going to be a collection of homogeneous elements. Homogeneous elements. Now, what does homogeneous mean here? Homogeneous means similar elements. And here, homogeneous is directly indicating the data type of the elements. Having the same data type can be referred to as an array. Now, let us first talk about that. Why was the concept of array needed in the first place, and why was this concept actually introduced in any given programming language? Since these concepts that we are studying here are not specific to C programming language, but they are used across the programming languages. Of course, the syntax might be different, but the underlying concept is gonna remain the same across all programming languages. So when assuming that arrays are not there, so how would you be working with the multiple values when you are supposed to be writing C programs? So you will be creating variables, you will be creating integer type, float types, and any data type variable that you would want to work with. So for the simplicity, I would be taking the integer, and let's say I want to work with 5 values in my program. Let's say I want to accept 5 inputs from the user, and I want to say find the sum of all those 5 inputs and return the sum to the user once again. Okay. So in that case, I would be creating 5 variables, A, B, C, D, E. The variable name could be anything. Of course, for the simplicity, I'm just taking them as the alphabet numbers or the names. So A, B, C, D, E. So what we'll be doing is you will be writing a different scanf statement, or you can probably use a loop in order to accept all these inputs from the user. And after that, you will be running a loop in order to add all these numbers, or in case you are accepting these separately, then you can simply say that the sum of all these numbers is going to be A plus B plus C plus D plus E. This is going to be the sum. Right? This was a simple enough program that I hope everyone can write here. But the complexity increases when the number of inputs that the user is going to enter become dynamic. When the number of inputs, or you can say values, that you will be working with become dynamic. That means while writing the program, you don't know how many values you will be finding the sum for, or how many inputs you will be receiving from the user when this program starts its execution. So what is happening is user is going to explicitly say, let's say the first input itself is going to be the number that will define that how many inputs the user is going to enter further. So let's say if the user enters 7 as the first input, you will have to accept 7 more inputs from the user. So this 7 was just a number, and after that user will provide 7 more inputs. If the user enters 9, then you will have to accept 9 more inputs. And in that case, of course, the code complexity is gonna be increasing here, because if you were using a different scanf statement for each of these variables, then it becomes a question for you that how would you go about implementing such thing? Because when you don't even know that how many inputs you are going to be accepting, how can you predict the number of scanfs or the scanf function calls in your C program, right? So of course, let's say we can there are some edge cases that you can probably think of by managing all these things. You can say that I am going to be accepting a maximum of 100 inputs, and whenever the user wants to end giving the inputs, then you can ask the user to enter some special symbol. Let's say if the user enters Q, or let's say if the user enters 000, something like that, then you will assume that the user is going to stop entering the inputs, and whatever inputs that have been, you will be finding the sum of those numbers. But these are some tricks that you should probably avoid as of now, because we have a better thing to implement here. We have a better concept that can be used in such situations, and it is arrays. Now in arrays, what you do is you don't need to define a different name for each of the value that you want to accept as input from the user. Instead, you can work with a single variable itself. Let's say I have a single variable A, and even if the user is going to enter 100 different inputs, then all those 100 different inputs are going to be accessed, or I am going to be accessing them with the help of the same name, which is going to be A. But remember, since A is a variable, it can only hold one value at a time. then how can I work with 100 different values with the same variable name? So what I would do is I would use these subscripts, I would use these square brackets, and here I would define that how many values this single variable can hold. And here, let's say if I write 10, then what will happen is this single variable a itself will become capable of holding 10 different values. Now the question is, if this single variable is capable of holding 10 different values, how do we access the fifth value or the seventh value or whichever value we want to access? Because if you write a, let's say if you write a, it is going to correspond to the first element. But if you want to move to second element or if you want to access fifth element, how would you do that? So the answer to that question is that once you write a syntax like this, A10, what the compiler will do implicitly for you is compiler is going to create 10 different values in the same variable, just that you will have to tweak this particular value that you are writing within these subscripts. So what will compiler do is compiler will say that A0 is going to correspond to the first element, A1 is going to correspond to the second, A3 is going to correspond to the A2 is going to correspond to the third, A3 is going to correspond to the fourth, and similarly A9 is going to correspond to the last element, or which you can say as the 10th element. Now you might be wondering that the 10th element should be represented with the help of A10. But remember, the first element that we represented here with the help of an array was making use of a number 0. And if you are starting from the number 0, you will always end up having 1 less than the actual length of that array. So if you wanted to work with 10 values, and if you are starting with 0 here, then the maximum number that you can go up to is going to be 9. Right? Because if you count from A0 till A9, you will see that you will be having a total of 10 elements. You already have 10 elements here. That's why the maximum index in an array is always going to be 1 less than its size. And this is also an important concept here, that the indexing, so this number that you are writing here within these subscripts, this is known as index. This is known as index. And index or indexes in C, they begin from 0. Indexes in C begin from 0, or you can say indexes are 0 based in C programming language. Right? And since the indexes are beginning from 0, the last element is always going to be having the index 1 less than the actual length of the array. Since we took the example of having 10 elements in this array called A, so that's why we ended up getting the A of 9 as the last element in the array. Similarly, if we would have created an array with a size of A100, the last element in this case is going to be A99, because we are again starting from A0. And if you count from A0 till A99, you will end up getting a total of 100 elements. Right? So this is just going to be the limit of the values that you are going to be working with. And the last value in a particular array is always going to be having the index 1 less than the actual length of that array. So are you able to understand whatever we have discussed so far?
Yes, sir.
All right. So once this thing is clear, now I would like to again come back to the problem due to which we started exploring the concept of arrays. Now that you know you have such a concept available with you, and you are supposed to be writing a program where user is going to enter the first input as the number of inputs that the user is going to enter, and after that you will have to accept those inputs and let the user know the sum of the inputs that he or she has entered. Now there are two approaches to solve this. One is that you actually create two variables. One is say n. N is just going to define that how many more inputs the user is going to enter, and the next variable that you are going to define here, let's say ARR, it is going to be an array, and the maximum size you can assume to be 100. That means you are saying that the maximum inputs that I am going to be accepting from the user is going to be 100. Now, firstly, you use a scanf function in order to accept what the value of n is going to be. That means the number of inputs that the user is going to enter. Once you know that how many numbers the user is going to enter, you can use a loop here. So let's say you use a loop here. You begin with 0, you go all the way up to one value less than n, and you always keep on incrementing the value of I. And here, now you will write this scanf call. And what will you accept from the input, from the user as input? You will accept ARRI as the input from the user, right? Because when the value of I is going to be 0, you are actually putting a value into ARR 0. Next time it will become 1. So you will put a value in a space called ARR 1, then ARR 2, 3, 4, 5, and so on, right? And as and when you are accepting this input, you can also keep it, or you can basically create one more variable here, say sum. You can keep on adding this new value that the user is entering in this variable, sum plus equals to this, right? So this is how you can solve this problem with a very simple concept called array. So array is what? As the definition that we discussed in the very beginning was that array is the collection of homogeneous elements, where homogeneous correspond to the data type. That means it is a collection of elements having the same data type. Now it is not possible for you to create an array where the first element is going to be an integer, the second element is going to be a float, the third element is going to be something else, and the fourth element is going to be something else. Remember, the syntax of creating an array is you first have to specify the data type, then you have to specify the variable name, and then in the subscript, you will have to specify the size, the number of values that you want to work with for that particular array. And now that we are saying that this data type could be anything. So this data type could be int. So you can say int ARR, and the size could be say 10. This is a perfectly valid array. Similarly, if you think that you will be working with some decimal or floating values, then you can define your array to be of floating numbers or floating decimals. Here also, what you are doing is you are creating an array of 10 elements, but now you will be able to store the values having precisions or decimals. And just because we can use any data type here while creating array, then we can also do this. We can also use char as a data type, and let's say the variable name is going to be str here, and I am going to be defining the size to be 30. So when you use the data type as char while creating arrays, it actually becomes another concept. Can someone name what this concept is, or what do we call such an array? What would you call an array of characters in C programming language? So it is a character
String.
array. Exactly. It is known as string. So character array is also known as string. So whenever you see strings in C programming, you can interpret it as a character array. Because a string is what? If you define string, then you will say it is going to be a collection of characters, right? And that is why a character array can be termed as a string value also, right? Because ultimately it is going to be having a collection of characters. And when you can use such concepts like you can actually create an array while working with the character type of a data type, that means you are actually working with a completely different entity, because when you are working with numbers, you are only able to work with number values. But now that you are working with characters as well, that means you can hold any value. Now you can think of any value means you can think about storing the names, because when you were working with integer type values or float type values, you could not store those values as part of your program. If you want to, let's say, accept some values as say the user name, let's say the user address, or probably some things that probably require the user to enter non-integer values. So name, address, right? There could be many other things that you would want to work with. So in order to work with these values or these type of logical things or entities, it is important for you to understand the concept of this character array, or it becomes important for you to implement the concept of character arrays or strings. Now, when you are working with character arrays, there are some additional functions that you can make use of, which will be provided to you by importing a library file called string.h. So string.h is basically a library that is specifically used for working with character arrays. So it basically gives you some utility functions. Of course, these are some utility functions. That means the coding for those functions has already been done before at some other place. and you don't need to worry about what that code is, how does that work. All you need to know about is that what is the function of that particular utility that you are working with. Right? Of course, whatever utilities that this library provides, it is very much possible for you to write it on your own as well. For example, the common utilities or the common functions that you get while importing this or after importing this string.h library is, can someone name a few functions with string library?
String copy, string compare,
Yeah, string copy. Say, okay, sorry, string
string length,
compare, string length.
String top
Anything else?
TOK.
Yeah, strtok. Uh, yeah, maybe these are the functions. So each of this function is going to make your life more easier because you don't need to worry about writing the code for this function. All you need to worry about is to understand that where and how to use this function. Just like this, strcpy, for example, it can help you in order to copy a value from one string variable into another. For example, if I give you a task, let's say you have to accept a character array or a string from the user, and you have to copy that particular value in some other character array. Now forget that you don't have this, or forget you have this strcpy function. You have to do it on your own. Then what would you do is you will actually have to write a loop. You will have to write a loop. You will have to go about parsing that particular character array from the index 0 up to its length, and you will have to keep adding those values into a new array. So you will have to write this custom logic by yourself in case you don't have this access to string.h library file. But if you have this access, all you need to do is you just need to call this function strcpy. You provide that where you want to copy. So you probably provide the target first, and then you provide the source. That means you want to move the value, or sorry, copy the value of the source into target. That means whatever the value of source is, that will be copied as it is into the target. Similarly, if you want to compare whether two strings are equal or not, which string is greater, which string is lesser than the other, that you can do with the help of strcmp. If you want to find out the number of characters that are present in a particular string, then you can use strlen. If you want to split the string by a given delimiter, then you can use strtok function. So there are some utility functions that are already been provided to you when you will import this string.h library file, so that your life becomes easier. You don't need to write this code again and again manually whenever you want to make use of this functionality. So someone, a programmer who faced this problem, has already written the code for it in some other file. All you need to do now is import this function and use it. You don't need to worry about the underlying logic. All you need to worry about is how to use this function and what benefit will you get from this function. Right. So this is about character arrays. This is about strings. You can use handy number of functions here in order to make your life more easy. So is this concept clear so far?
yes sir.
All right. So after that comes the next concept is going to be pointer arithmetic. Pointer arithmetic. So pointer arithmetic, especially with arrays. So what you do is, let's say you create a pointer, a variable or a array here with 10 elements. And now what you want is, you want this array to be referred by a pointer. So what you would do here is you would create a pointer here, let's say int star p, ptr, whatever you want to name it. And you would say that I want this pointer p to be referring to this particular array. So if you want a pointer to be referring to a particular array, then this is how you should be doing it. I am giving the starting index as 0. That means this pointer will start referring to the beginning of this array. It is entirely possible for you to write a syntax like arr2. Now this pointer will actually refer to the third element of the array. The pointer will start referring to the third element of the array. Since it is the second index, that means it is the third element. So this depends upon your implementation, which index you want the pointer to be referring to. And once you have done that, you would be able to access all the values of this array with the help of this pointer itself. If you say star p That means you are trying to access the value of ARR0 element. Similarly, if you try to make a jump of, let's say, p plus 1, then you want to actually make a jump of one element here. In that case, what you are actually trying to do is you are trying to access the first element in the array. Similarly, if you say p plus 2, then you are trying to access the second element or the third element in the array, which is having the index second. And similarly, if you say star p plus n, that means you are trying to access the nth element, right? The nth element in that array. So, the replacement of this ARR1 or ARR2 is going to be with the help of these pointers. And if you say p plus 1, you are actually trying to refer to the next element in the array. And why the pointer behaves like this is something that you also need to understand. We have discussed about the concept of arrays. We have discussed the definition. The definition says it is the collection of homogeneous elements. But there is one more property, there is one more feature that the array provides, which is the contiguous memory allocation. Contiguous memory allocation. Does anyone know what is the meaning of this contiguous memory allocation term? Does anyone know? Anyone?
Yes, sir.
Yeah, go ahead, please. Do you want to say something about this concept, contiguous memory allocation? Anyone?
Means the memory will be allocated of one block after the other. Continuously.
Exactly. And this is guaranteed in case of arrays. All right. So let me talk about this concept as well. Contiguous memory allocation. Now, if you do int a, b, c, d, e, if you do or create variables like this, the contiguous memory is actually, or allocation is not guaranteed here. It is entirely possible that this a is actually assigned a memory block of 100. This b is assigned, let's say, 178. This c is assigned some 128, something like that. You cannot predict whether it is going to be contiguous or not. But when you are working with arrays, it is guaranteed that the memory allocation for all these elements is going to be contiguous. That means ARR0, ARR1, ARR2. Okay, I'll just go up to ARR3. Now, if this ARR0 got the memory 100, in that case, it is certain that this ARR1 is going to get the memory address of 104. If we are assuming that the size of integer is 4 bytes. If the size of integer is 4 bytes, so this ARR0 is actually going to be consuming 4 bytes. So 4 bytes means 100, 101, 102, 103. So till 103, ARR0 will consume. Then from 104 onwards, ARR1 will start consuming. Then ARR2 will start consuming from 108, and ARR3 will start consuming from 112. So this memory allocation here is happening contiguous, and it is guaranteed in case of array. Now, since it is guaranteed, that is why you are actually able to, learn the concept of pointer arithmetic. Because just like I told you that if you want to refer to this particular array with the help of a pointer, you would write a syntax like int star p equals to and ARR0. Then what is actually happening is you are saying that this pointer, in the code you are saying that it is referring to the 0th index element of this array. But actually what is happening behind the scenes is that this pointer will start referring to this 100. This pointer will start referring to this particular memory location, which is 100. And now when you do p plus 1, it doesn't matter, to this pointer that it has to go to this second element in the array. What will it do is it will actually make a address jump. Since it knows that it is referring to a value which is having a data type of integer, when you do plus 1, it will understand that since integer is going to consume 4 bytes, it has to make a jump of 4 bytes here. And when you say p plus 1, it will understand that it has to make a jump of 4 bytes. So it will automatically start referring to a memory location of 104. That is why p plus 1 will automatically start referring to the next element in the array. Why it is actually referring to the next element in the array? Because the next element is allocated the contiguous memory. And this only happens in case of arrays. Because if you create 5 different variables and you refer this a variable with the help of a pointer, and you expect that p plus 1 is going to give you the access to this p, that is not guaranteed. Maybe in some rare scenarios this could happen, but where can you get a guarantee for this is in the case of arrays, because in the arrays you are getting a guarantee for contiguous memory allocation. The pointer is relying on this particular contiguous memory allocation concept, because when you do p plus 1, it doesn't know what the next element of that array is. All it knows is that it has to make a jump of one memory address wherever it is currently present, and depending upon the data type this particular pointer is referring to, it is going to decide that how many bytes jump it is going to be making. If this pointer is referring to an integer value, then it is going to be making a jump of 4 bytes. If it is going to be referring to some, say, short integer, then it will make a jump of 2 bytes. If it is referring to a character value, then it will only make a jump of 1 byte. So when you do p plus 1, it becomes important for you to know that which type of value this p is referring to. If this p is referring to an integer value, it will make a jump of 4 bytes. If it is referring to a short value, it will make a jump of 2 bytes. If it is referring to a character value, it will make a jump of 1 byte. So this is how this pointer arithmetic works behind the scenes. Are you able to understand this?
Yes, sir.
All right. So this is all about arrays, strings, or a little bit overview of these 3 important concepts that have been discussed as part of this particular 7th week, where we discussed about arrays, we discussed about character arrays, which are also termed as strings. Strings come with some utility functions. If you import the library file string.h, and it gives you the access to those utility functions. And in addition to that, you can also perform pointer arithmetic once you start working with arrays. And pointer arithmetic is only possible because of the feature of the array that you get, which is contiguous memory allocation. I hope this is clear to all.
Yes, sir.
Yes, sir.
All right. So now let us try solving a few questions that are based on this particular week 7. So I shall navigate to mock unit. Okay. So this is based on pointer, not on arrays. Okay. Do you guys know about the NDNS? The 2 types of NDNS, big NDNS and little NDNS?
I think this were explained in the last session, sir.
Okay, if this is done, then maybe I can skip this. 10th question is about array. So yeah, maybe this is the question we shall be starting with. Maybe let me increase the size, zoom in a bit. I hope this would work. So this 10th question is saying that you have to select all the true statements about array initialization here. So the first statement here says arrays can only be initialized at the time of declaration. So that means it is telling you that when you create an array, let's say ARR having a size of 10, then it is mandatory for you to initialize this array here only. If you don't do it here, you won't be able to do it afterwards. Do you think it is true?
It is false, sir.
No, sir.
Yeah,
False.
because it is entirely possible for you, once you create an array, to go and change a particular index. Let's say you can assign it a value of 9. Similarly, you can go and assign this 9th index to be containing a value of 20. So this is entirely possible for you. And since we are able to do this, first option becomes wrong. The second option says arrays can be initialized both at the time of declaration and later in the program. And this is something that is true about array initializations, because you can actually do it at the time of declaration as well as afterwards. So second option makes sense, and it is going to be the true statements. The rest of the 2 options are going to be false, but let us just go through over them. Arrays can be or can only be initialized with integer values. No, it is not possible, because we have seen that the syntax of creating arrays is defining the data type. The data type has to be specified. And when you are able to specify the data type, that means it is always possible for you to work with values other than integers. You can work with float type values, you can work with character type values too. So third statement becomes wrong. The fourth statement says the index of the first element in an array is always 1, which is of course wrong, because we have discussed about it as well, that the indexing in C is 0 based, or the first index is always 0 in case of a array in C. So I hope this question is clear.
Yes,
Yes,
sir.
sir.
All right. Now in the next question, it says, consider the following code. What will be the output of the C program? So what is it doing is, it is creating an array having size 8. It is initializing the first two elements in that array, having indexes 0 and 1 with the values 1 and 2 respectively. And then it is starting a loop, which is beginning from the value of I to be 2. And it is going all the way up to the last index of this array. And then it is saying that the value of the current index of the array is going to be the multiplication of the previous two elements. Okay. So that's a good question. So you basically have an array here, let's say ARR, which is having the size 8. You are saying that ARR 0 is going to get the value 1. ARR 1 is going to get the value 2. Then you shall start a loop here for, say, I equals to 2. I'm just writing pseudocode here. I'm not writing the, a full-fledged syntax of C programming. Just writing pseudocode, I++. And here what you are doing is, you are saying ARRI is equals to ARRI minus 1. Is it multiply or plus? It's multiply. So you are multiplying it with I minus 1 or I minus 2. And then you will go about doing this. And at the end, you want to print the value of ARR 6. So that means, as long as we will be able to get the value of ARR 6, we can stop. We don't need to go, more further. So let's see. Since this I is getting initialized with the value 2, that means the very first element that is going to be overwritten here, or is going to be getting the value, is going to be 2 here, ARR 2, which is going to be the third element. And if it is asking about ARR 6, that means it is asking about the 7th element. Okay. Let me, keep that array somewhere here. First delete this from here. And I will keep this array here. So first element is 0, next element is 1. Fine. Now we are talking about ARR 2. ARR 2 is going to be ARR 2 minus 1, which is 1, multiply ARR 2 minus 2, which is 0. So what is the value of ARR 1 and what is the value of ARR 0? It is not 0. It is actually 1 and it is 2. These are the first two elements. So what will be the new value for ARR 2? It will be 1 multiply 2. It will actually be 2. Do you agree with this? Do you guys agree with this?
Yes,
Yes,
sir.
Yes, sir.
So the next element that we will get in this array is going to be 2. Fine. It's time to go to the next iteration. The next iteration, the value of I will become 3. And now you will say that the value of ARR 3 is going to be ARR 2 multiply ARR 1. So now you have to multiply the last two values. The last two values are 2 and 2. So you have to multiply them and get the result, which is 4. So 2 times 2 becomes 4. Fine. You move to the next iteration. Next iteration says you have to multiply the previous two values and find out the result. So ARR 4 is going to be ARR 3 multiply ARR 2. So it is going to be 4 times 2, which is going to be 8. You get the next value, which is 8. You go to the next iteration, which says ARR 5. So the value of ARR 5 is going to be ARR 4 multiply ARR 3. So 8 times 4, which is going to be 32. And now we have come to the actual element that we want to find the value for, ARR 6, whose value is going to be ARR 5 multiply ARR 4. The last two values, which are 8 times 4. Okay, sorry, this is already done. So 32. 32 times 8. What is going to be the answer?
256.
256. Okay, fine. So 256. That means the answer to this question should be 256. Of course, the program will execute further because it also has to find out the value for ARR 7 as well, since this loop will run. But the question was only asking for ARR 6, and that's where we stopped, and we will be able to save some time here. Fine. Same strategy you will have to apply during exams as well. Make sure you read the question at least twice so that you don't end up doing extra steps which are not required for that particular question. So I hope this question is clear to all.
Yes, sir.
Yes, sir.
yes, sir. Clear.
The next question says it is creating a character array here, which is having a size of 10, but it is only providing 5 characters to that particular character array, and those 5 characters are HELLO, which is forming a string or a word called hello. And it is trying to find out what is the size of A, what is the length of the string A, and it is trying to find the sum of these two values. So if I'll ask you what is the sum, or sorry, what is the length of the string hello? The length of the string is going to be 5 or 6. strlen is one of the utility functions that you get after importing string.h library file in your C program. What does it do is it gives you a count of the number of characters that are present in your string. But the question is, does it include or count the null character as well? What do you think? Does the strlen function take null character into the count as well? Okay, so the answer is no. It does not take the null character into the consideration. So the size that it will tell you about the character array A or string A is going to be 5, because there are only 5 characters present. But if you have to find out the size of A, can someone tell me what is size of A here?
Ten, sir.
And
Size of A here is 10, because we know that the length of this character array is 10, and a character consumes 1 byte in the memory, in the RAM. So 10 times 1 becomes 10. So size of A is actually going to be 10 bytes. Okay. It returns value in bytes. And strlen is giving you the value 5. So 10 plus 5, the answer should be 15. It should be the second option. I hope it is clear to all.
yes, sir.
All right.
Sir, what happen if it will be considered as an int?
What happened if
Instead
which is
of
considered
char,
as
instead of char, it will be a int.
okay? Then you are asking about the size, is it?
Yes, sir.
Then the size will become 4 times of
40.
what the 4 times 10 becomes 40. 40 bytes will be the total size. Okay, so here is another question. This is importing this string.h library file, and that is why it is able to use this strcmp function that you can see here. Okay, so it is saying it creates a pointer here. S ultimately it is creating a kind of character array here, and it is trying to store a value hello C, programming this long string into this pointer called S, and then it creates another pointer P, which is starting referring to the element, some element from this S pointer only, or from this S character only. How is it finding, or how will you be able to know that which index or which character this P pointer is going to start this array referring from? You have to remember the concept of the pointer arithmetic. If it is saying hello, HELLO C programming, so this is index 0, 1, 2, 3, 4. 5th is the index for this space. 7th is also the index for this space. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So a total of 22 characters exist in this particular array called S. So this is what S is saying. Now P says that I will start referring to this array only, but I will first take a jump of 6 bytes. Now, remember that this P is of character type. And when you will be saying that it needs to take a jump of 6, it needs to take a jump of 6 depending upon which type of data it is referring to. It is going to decide that how many memory locations it is going to jump. But since we are dealing with characters only, that means or every character has a size of 1 byte. And if you are taking a jump of 6, that means you are taking a jump of 6 multiply 1, 6 bytes only. So if S was referring to this 0th index, you are taking a jump of 6. So if you will take a jump of 6, where will you reach? Which index? You will reach index 6 here, right? If you take a jump of 6, first jump will make you reach here, second here, third here, fourth here, fifth here, and sixth here. That means this pointer P is going to refer to the string C programming. S is referring to hello C programming, but P is referring to C programming. It has scrapped out this hello and this praise part. Going further, it says it creates another value Q, C programming. So Q, it explicitly says that Q is going to be C programming. This is the value of Q pointer. And now what it is doing is it is saying that I have to compare two string values. I have to compare the value that is present in this P and this Q. And if both of those values are equal, so STR, the way it works is that if the values that you have provided to strcmp function, if they come out to be equal, then it is always going to return the output as 0. If the two values are equal, then it will return the output to be 0. But if the values are not equal, then it can return a positive or a negative number depending upon which value is greater. Okay. So does anyone know how does strcmp work? How does it work internally? Though you don't need to worry about what the internal implementation is, but does anyone know how does it work behind the scenes? Okay, so let me tell you. Let's say you are provided two strings. One is hello, HELLO, and the next is going to be HELLO. Here, this L is actually capital and this is small. That's the only difference. If you will say in English, then there is probably no difference at all because one is small, one is capital. You will probably don't mind, seeing this difference. But in programming, what happens is the way strcmp will work is it will start parsing both the strings starting from the 0th index. So the very first thing it will do is it will see what is the value present at the 0th index of both the values provided. So firstly, it will see for the first value, it is H. For the second value, it is H. Both are same. If both are same, it will move to the next character or the next index. Next index is E for the first value and also E for the second value. It will say, okay, both are equal. It will move to the next index. Next index says it is L and it is L here. Now remember, what was it actually comparing here? Can someone tell me what was being compared when this H and H was compared?
The ASCII values.
The ASCII value was actually being compared. The ASCII value for H, whatever it is, of course, it is going to be the same for H. For small e, it is going to be the same. But when you talk about the ASCII difference between a small and a capital letter, it is a difference of 32, right? Because capital A is represented with the ASCII value of 65, whereas small a is represented with the ASCII value of 97. So 97 minus 65 is a difference of 32. So there is always going to be a difference of 32 between the uppercase and the lowercase character. And the same difference will exist here too. Here, the capital L is going to be holding a greater value than this. Sorry, the small L is going to be holding a greater ASCII value than this capital L. And that is why here it will say there is a mismatch. And the way strcmp function will work is it will not even move further. It will straight away return you a number, a posit, depending upon which string was provided before. So since you are providing two inputs, strcmp, first input is here, second input is here. Now, whichever is greater, let's say if S1 is greater, let's say this HEL was S1 and this capital L was this S2. So since this was the first parameter to this strcmp, it will always deduct the ASCII value of the second value from the first. So let's say if the ASCII value here is just an example 102 and let's say this is 70, right? So the difference here came out to be 32. Then what will it do is it will return the same number as the output. So strcmp is going to return you this 32 number. And if you get a positive number here, a positive number of 32, you can make a guess or you can interpret it as that this S1 value is actually greater than this S2. Similarly, if it would have returned you -2, that means S2 is greater than S1. But if it returns you 0, that means both the strings are the exact copies of each other. That means both the strings may be having the values hello or any value that are synonymous. So this is how the strcmp function works behind the scenes. Are you able to understand it?
Yes, sir.
All right. So now, given that the value of P is this, which is C programming, the value of Q is the C programming, and these, of course, exclamatory marks. What do you think? What is the number output that you will get from this strcmp function call here? Can you guess? Do you think that both the strings are equal? C programming and C programming, are they equal?
Yes, sir.
Yes, both of these values are actually equal. And since they are equal, the strcmp function is going to return you an output of 0. And since you are getting an output of 0 here, which is actually being compared against 0, since both the values will match, what will actually be printed on the console is matched. The control will not enter the else block. Instead, it will print this matched value because this condition became true. This expression became true. So the output here is going to be matched. Is it understood to all?
Yes, sir.
All right. Okay, so this is a concept based on structures. Fine. So we have discussed all the important concepts from week 7. It's time to move to week 8. In week 8, we are taught about 3 more user-defined data types. And those 3 are structures, unions, and enums. Okay. Let us first talk about structures. And I would like to talk about the same example through which we understood the importance of arrays. Okay. So we understood the importance of arrays with the problem statement that when you are not sure about how many values the user is going to be entering as input or how many values you as a programmer is going to be working with, then you will go with array because it gives you the flexibility of having multiple values in the same variable. But now my question is, previously the user was only entering some numbers. Now what the user says, now I don't want to enter numbers only. Instead, I want to enter the name and the age. I want to enter the name and age for 10 different people, 50 different people, 60 different people. Again, this is a dynamic number which the user will specify as the very first input of the program. As the very first input of the program, say it is n. Here the user will define that how many user inputs the user is going to be providing. And each user input will have a name and an age. Now that you have to work with name, what would you do? Because the array can, of course, hold elements having the same data type. So one of the solutions is that you will actually create 2 different arrays. You will create 2 different arrays. One is going to be this char names. But remember, when you will be creating a character names array, if you do it like this, say 30, then how many names can you hold in this? Can someone tell me how many names can you hold in such an array? Similarly, you will be creating, let's say, int ages, and this is also 30. This can definitely hold 30 different numbers. But do you think that this implementation or this syntax can hold 30 different names? Do you think that?
No, sir.
No. It can only hold a single string that can have a maximum number of 30 characters. So in that case, what you would have to do is you will have to convert this into a 2D array. You will say the maximum values that I will be working with are 30, and the each value, that means the each name that I am working with, can also have a maximum of 30 characters. So you are saying that I am working with 30 different names and each name can have 30 characters. So you will actually have to create a 2D character array when you want to work with names. So here itself, it becomes very complicated for you. Because now, when you will actually start writing the program for it, you will say that names I is actually going to be referring to the first, I would say, the name the user has entered or the ith name, and ages I is going to give you the access to the ith input that the user would have entered. But remember, this names is a 2D array now. So this I is actually referring to an entire row. It is referring to an entire row, which will probably be the name of a given user. Okay. So what you will have to do is you will have to always trust the indexes. That if, let's say you want to access the fourth person, so you will say names. You will say names 3. Since you are saying fourth element, so since indexes begin from 0, the correct index for the fourth element is going to be 3. Names 3 is going to give you the name of the third person, and you will have to go about ages this way only, ages 3. So ultimately, the maintainability, it becomes difficult for you to write a program of this sort, because now you are already working with 2 different arrays when the information actually correspond to the same person or the same user. The name and age that you are getting from the user is actually for the same person, but you are actually storing those values in 2 different places. And that is where the arrays concept, the concept of this array, becomes a little bit difficult to implement for such scenarios. Because what we have to do here is we have to store data which is actually grouped into a logical entity. So if you are saying name, age, tomorrow the user can say, I want to store the address, I want to store the roll number, I want to store the 10 different things for a particular user, then it becomes more difficult. You will have to keep on creating those arrays as and when the user information is getting incremented. So the solution to such type of problem is going to be structures. In structure, what you do is you define that what all are the attributes that the user is going to enter for a given person. So let's say it is going to enter the age, fine. It is going to enter the age, so I will define age, and it is going to enter the name, fine. I will have this name here, and the maximum size that I am going to accept for a name is going to be 30. Let's say tomorrow, if it is going to accept the roll number as well, I can even accept roll number here. I can even accept roll number here, and this now becomes, all these 3 variables are a part of a single variable. All these 3 variables, I'm repeating it again, all these 3 variables now are becoming a part of a single variable. A single variable. And how is it different from an array? Because you would say that, of course, I can do the same thing with array. In array, what I was doing is I was holding multiple values in a single name. The same thing is happening here. I am holding multiple values in a single name. But what is different here? Can someone tell? What is different here? Here also you are actually working with multiple values in a single variable. But what has changed in comparison to arrays? What has changed is actually the data type. The data type has changed. In arrays, you are working with multiple values in a single variable, but all values were belonging to the same data type. But here you are working with multiple values in the same variable, but each of that value can be having a different data type. Age is having integer, name is having character, roll number is having integer, maybe the mobile number can be having float, maybe the marks can be having double, and things like that. So ultimately, you are able to work with multiple values with the help of a single variable, and now you are able to work with heterogeneous data types. That means different data types. The way you would work with it is, let's say you have written this and you would name this as an entity. So just before this struct and this curly brace, you would have to write some name. Let's say I'm writing it as student. Now, how would you create a variable for this particular entity that you have created here? In the code, you would write struct student S1. The moment you do that, this S1 variable has access to 3 different properties. One is age, one is name, the other one is roll number. That means what you can do is you can say S1.age is going to actually give access to the age. S1.name is going to give you the access to the name, and S1.roll number is going to give you the access to the roll number of that particular user only. Now, what you are able to do is in the same single variable S1, you are able to group the logical data, because a user data which should be stored together with the other user details, you are able to achieve that feature here or achieve that requirement here, because you are able to store all the relevant user information in the same variable, which is this structure. This S1 variable will be able to hold age, name, roll number, address, or any other attribute that you can probably have in the future in your system. Are you able to understand this concept?
Yes, sir.
Yes, sir.
All right. And now, how can you make this concept more powerful is you can combine this concept of structures with the concept of arrays. What you can do is when you are saying struct S student S, then you can also put this subscript here and say 10. Now what you have is you have 10 different student type variables. So you have S0, you have S1, you have S2, and this will go all the way up to S9. And each of this S0, 1, 2, 3 that you are seeing here, each of this will be having its own copy of age, name, and roll number. And this is the perfect example for the problem that we have just discussed, where the user is supposed to be entering the age, name, roll number, and many other details for a specific user. And the user is going to details or enters as details for many users in the same program. So what you can do is you can create an array of structures, and each structure variable, that means this S0, S1 is going to be keeping or holding the information of a single user. So the single user is actually wrapped into a logical entity that we are calling as struct here. I hope this is making sense to you. All right. So this is about structure, and you can combine this concept of structure with the help of arrays, and you can make it more powerful. Right? For example, for solving the problem that we have just discussed. Right. So this is about arrays. You can basically group logical entities into a single wrapper, and you can go about adding as many attributes as you want. Right? Currently, I just took example of 3 attributes, but it is entirely possible for you to have 100 different attributes, and each of that attribute can be having a different data type. Doesn't really matter. Right? After that comes the concept of unions. Union is also a user-defined data type, just like structure. Does anyone know what is union? Does anyone know what is union? When should it be used? Okay. So see, union is very, very similar to, the syntax is almost similar to structure. The only difference is going to be the keyword. Previously, we were using struct in order to create a structure, and here we will just use union. We will say union and say some name. It is going to be the name of the union, and the same thing that we have done in structure. Here I would say int, it was age, it was name, say 30, and then it is having this roll number. But the difference here is that if you create this as a structure, if you don't use union here, instead if you use struct here, then can someone tell me if you will write struct name S1, what is going to be the size, the minimum size of this S1? Let's not talk about the actual size, because that may depend on the padding. I'm talking about the minimum size for this S1 variable if this is a structure. Can someone tell me the minimum size?
So 38.
Yes, the minimum size is going to be 38 because int will take 4, this will take 30, this will take 4. So 30 plus 4 plus 4 becomes 38. So 38 bytes is the minimum size that a structure variable will take. But what is happening in union is you are just trying to optimize your code to some extent. So what the concept is that when you are writing multiple properties, you are writing multiple properties here because you need all of these properties as part of your program, but you don't need any 2 properties at the same given time. I am going to repeat this statement once again. whatever properties that you are writing as part of this union, all of these properties are definitely required while working or while writing that program. But no two properties are required at the very given same instant. That means if you want to access a particular value, you will either access age at a time, you will either access name at a time, or you will either access roll number at a time. You will not access all of these values at the same time. If there is such requirement that satisfies this thing that we have discussed, in that case, union is best suited, because the way it will work is it will not allocate the memory for each of this attribute that you are creating here. Instead, what it will do is it will only allocate the memory for the largest member in this union. So what is the largest member here? Can someone tell me? The largest member is the character name array here that you are seeing. And what it is going to do is it is going to create a fixed size for this union variable, which is going to be having 30 bytes. And now, once you have allocated 30 bytes to it, what is going to happen is these 30 bytes are going to be reused for age, because age only requires 4 bytes. Of course, you can have 4 bytes in 30 bytes anywhere. Similarly, roll number is also going to take 4 bytes. So the idea is that you will allocate memory for the largest member only, and that memory will be reused for all other members that are present in the same union. And that is why you are saying that no two values will be accessible at the same time, because when you are working with age, that means this entire memory chunk of this 30 bytes that you are seeing is actually having this 4 bytes. Of course, the remaining 26 bytes are there, but that 26 bytes might have some corrupted data, might have some garbage value. So when you are working with age, your age will actually be stored in this chunk of 30 bytes only. When you are working with name, it is going to be stored in this chunk of 30 bytes only. When you are working with roll number, it is going to be stored in this chunk of 30 bytes only. Since we have agreed onto the condition that we will not be using two values at the very given same instant, the same 30 bytes chunk will be utilized for all the different attributes of this particular union. In this way, what we are able to achieve is we are able to achieve optimization, the actual memory optimization, because where in case of structure, you were requiring 38 bytes for only a single variable, here you are only needing 30. Of course, if you will be adding more values here, and let's say all of them are integer, then the structure size will actually increase, you will say linearly, but here union size will not increase. It will become constant, because once you know that the maximum size of a given member is 30, then the maximum size of a union variable, or the fixed size of a union variable, is always going to be 30, because all other variables will come here, will be utilized, will go. Then the next variable will come, will use the same chunk, will go. Okay? So this is where the union comes into the picture. This is just for you to optimize your program or optimize your program memory to some extent. Are you able to understand the idea?
Yes, sir.
Yes, sir.
This is what yes. Someone saying something? Okay, fine. So I hope you got the idea. This is what a union is. Now, coming to the last data structure, which is enum. Okay, does anyone know about enum?
So we write the code on enum and just like a sequence.
Okay, you write the code in an enum just like a sequence. Can you elaborate it, please?
Sir, just like this, we print the month, Monday, Tuesday, Wednesday.
Yes. Okay, understood. I get your idea. Firstly, I would like to make it clear that enum is actually being used or being created for enhancing the code readability. One major thing that it does is it actually enhances the code readability. I would like to take the same example that some student has already taken here. Let's say you are working on a system which which is working with months. Okay, so months will start from Jan, then comes Feb, then March, and it will go all the way up to December. the month that we are currently in, right? Now, what happens is you actually, since you are working with these things, you will be storing these values somewhere, like in some given data type, in some database. Let's say you are storing these values, these month values in some database. Fine. The first thing is when you are storing this entire January value, this entire February value, all of these things, each byte or each given extra character that you are using here is going to be taking extra bytes in the memory in the actual database that whichever you are using. So what happens is, in order to solve this problem, since you have to store this entire January, February, so each character is taking 1 byte, and the number of characters which are getting increased here for each month, of course your storage size is going to be, well, this is not going to be a big concern, but I'm just letting you know so that you can understand the concept behind enums. This is not a big concern, I'm again telling you. So what someone does is, let's say I'm creating such a system where I want to work with all these months, and I don't want to store this entire month value in my database because I want to avoid the usage of storage to the extent possible. So instead, what I did is I said that I am going to be assigning a unique number to each of this month, and I am going to be storing that particular number in my database, and in my code, I will create a map that this number corresponds to this month, this number corresponds to this month. So I will say January, I will assign it a unique number 0. This I will assign it 1. This I will assign it 2. And similarly, this will get the value 11. Right? So ultimately, what you are storing in place of January in database is 0. In place of February, you are storing 1. In place of March, you are storing 2. So of course, you have reduced the storage size to some extent by storing this single digit only. And when you are trying to read from the database or when you are trying to write into the database, you understand that 0 means Jan, 1 means Feb, 2 means March. Now, the very first thing is that why do you actually need to know this? Why do we actually need to know this? That 0 actually corresponds to Jan, 1 actually corresponds to Feb, 2 actually corresponds to March. Because your business logic is dependent on that. You have converted the January into 0 value for a purpose so that you can basically reduce your storage in the database. That's why you decided to assign it a unique number. And the map that you are creating here, this map, where the January will correspond to a number 0, Feb will correspond to a number 1, March will correspond to a number 2, this itself is actually known as enum. This actually is known as a enum. Because now, when you are going to be using this value 0 in code, you know that 0 can be represented as the value January. Now, I have a very simple question for you. When you are processing this value 0 in your business, in your system, or let's say you are writing a C program itself, and you want to process this value 0, would you prefer to write the value 0, or would you prefer to write the value January in your code? What would you prefer more?
Right to January.
You would prefer to be as much explicit, as much specific as you can, right? Or as much descriptive as you can. Because when you are writing some code, it is very much possible that if you will read that code tomorrow, or let's say after some time, you might not be able to immediately grasp the context that why did you use this 0 and what did this 0 correspond to or belong to. In that case, if you would have written this January in that place of 0, then it would be immediately easy for you to understand, okay, January is pretty much easy for everybody, or even when someone is writing code, it is pretty much easy for them to understand. Even when you are doing code reviews, or when the code reviews are happening, or even you yourself are reading your code after a long time, then this descriptive things that you are using in your code base, this is going to save you a lot of debugging time, because you already know this 0 is actually being converted into January. So what is happening is the value that is getting stored into the database is actually 0 only. But when you are retrieving that value, when you are processing that value, you are going to be writing a descriptive name January, because you have already created a map here that January actually corresponds to 0. So when you are writing January in your code base, you are actually writing 0. You are actually working with the value 0. Similarly, if you are writing a value February, you are working with a value 1. It's just for the programmer's readability, you are writing February so that it becomes easy for you to understand. It becomes easy for your peers to understand. So this map that you are seeing here, this map itself is the enum. Just like we have created the struct, union, etc. Similarly, you can create enums the same way. Enum, the name of the enum, and here this, and then you can start writing the names. So let's say Jan, then Fab, then March, and then April, etc. You can go ahead and add all the values, possible values that you want to have. So by default, the very first value that you will have in this enum is going to be assigned a decimal value 0. Fab will be assigned value 1. This will be assigned 2. This will be assigned 3, and so on. Right? If you want to change the assignment, that means you don't want this Jan to be given a value 0, that you can also do. You can explicitly say that Jan should be assigned a value 3, Fab should be explicitly assigned a value 5. This is entirely under your control. But what you are getting here is you are getting code readability, because when you will be creating a value for this, when you are creating a value for this enum type value, let's say enum name, now you will say month, enum say month. Now, if you will say month equals to January, you are saying month equals to January, but ultimately what you are saying is that month equals to 0, because January implicitly has a meaning of 0. You are writing this January here just for the just for the descriptive purpose, so that you can understand this code after a given time, or even your peers can understand this code that you have written. So are you able to understand the idea behind creating enums? This is just a map of a descriptive value to an internal value. Are you getting it?
Yes, sir.
Yes, sir.
Fine. If this thing is clear, then I would like to move to solving a few questions. So here, it is providing us with a C program here. It has created a structure called score, which is having two attributes. One is roll number, other one is marks. It has created a print score function, which is accepting a pointer to this structure type variable or structure type object. And it is saying select all the correct implementations of function print score if the output of the above program is this and this. So you basically create a structure here. This first value that you are writing here will go to the first attribute, which is roll number. The second value that you are writing here will go to the second attribute, which is marks. Now, you are passing this object here, S1, to this function here, and it is asking you that what should you write inside that function so that you get the output to be this. That is 10,001 and 80. What do you think? What should be the output, or what should be the code? Remember, if you are working with structure variables, if you are saying struct score, say S1, then the way you will access its properties is going to be using dot operator, S1 dot ABC, S1 dot XYZ. But the moment you create a pointer here, the moment you create a pointer struct score pointer S2, now you will not use dot operator anymore. You will start using arrow operator now. If you are using a pointer, then you will start using arrow operator in order to access the properties. So ABC, same property which you are able to access with the same object S1. You are able to access it using S1.ABC. Now you will have to use S1 arrow operator ABC. And XYZ, you will have to use S1 arrow operator XYZ, just because this S2 is now become a pointer. This is not the object. This has now become a pointer. Now, remember, this print score is actually getting a pointer here. So what should be the correct answer, which should give you this value or output? 10,001 and 80.
Option number 3.
First dot operator is being used. Here, there is no reference to the pointer. And third option is the correct one, which is making use of the arrow operator and referencing to the correct values. Right? Okay, this is based on enum. We have already discussed about it, and here it is explicitly giving a value of 5 to B. That means A will only get the value 0. A is again going to get the value 0 only, but B will start getting value 5. And the further values that are written afterwards, that means C will get 6 and D will get 7. So it is saying it creates a variable VAR here for this enum level, and it assigns a value D to it. So can you tell me what is going to be the decimal conversion for this value D here?
7.
It is going to be 7. So the answer is going to be 7 here. All right. This is a question about union. In a union, how is memory allocated for its members? So we have to find out the true statements here. The first option says each member gets its own separate memory space of a fixed or equal size. What do you think? Is it correct or false?
Sir, wrong.
Uh, exactly, it is wrong, because the entire purpose of creating a union is because we want to share the space between the members of the union. The second option says allocated memory is shared among all members and the memory size is equal to the size of the largest member. Is it true?
Yes, sir.
Yes, that's true. And that is why we use enough, because we want to share the same space among all the members of the union. The third option says allocated memory is shared among all members and the memory size is equal to the size of the smallest member, which is wrong. Because if you define the size of a union variable to be the size of the smallest member, how will you be able to accommodate a attribute which requires more memory than that? So that becomes wrong. The fourth option says the size of the allocated memory is equal to the sum of sizes of its member. That is also wrong. Now, question number 17 is talking about type def. So yeah, I think I forgot to discuss about type def. So see, type def is actually a keyword in order to create a new data type. The syntax of type def is firstly you write type def. After that, you write a data type here. You write a data type. And then you write a alias. You write an alias for this data type. So the example is type def, and let's say you specify int here, and you write say abhi, just for an example. Now what will happen is from the next moment, the moment you have written this code, if you wanted to create an integer value, you could have written int a. That is fine. But now even if you write abhi a, then also this a will automatically understand that it is actually an integer type variable, because you have said that you want to create an alias for this int with the name abhi. So wherever you will use abhi, it will by default mean int. So ultimately type def is used in order to create an alias for an existing data type. Okay. Now what is happening here is it is saying type def int star int ptr. It is saying type def int star and it is saying int ptr. And it is asking what does int ptr represent in this declaration. So ultimately, if you will write anywhere int ptr, and you will create a variable, let's say a here or let's say p here, then what is going to be the type of this p? Can someone tell me what is going to be the type of that p? Sorry.
Pointer integer.
Exactly, it is actually a pointer to an integer. So when you write int star, so whenever you create a pointer like this, you actually create an integer pointer. So the same thing is happening here. You are actually creating a pointer to an integer. Just allow me a moment, please. Apologies for the delay. Yeah, so I think we had discussed so far that typedef can be used to create an alias for an existing data type. And here the answer is going to be pointed to an integer. Okay, so this is based on dynamic memory allocation. All right, so this means we will have to move to the next discussion. So structure, unions, enums, and typedef, these were the important concepts that were taught as part of week 8. Now it's time to come to the last week, which is week 9, the last week for today's discussion. Week 9, where the major thing that has been discussed is actually dynamic memory allocation. Dynamic memory allocation. Okay. But before understanding dynamic memory allocation, you have to understand what is static memory allocation. So can someone tell me the difference between static and dynamic memory allocation? Can anyone tell me? Okay. All right. So see, as the name suggests, static means that you are telling the compiler, you are telling the C compiler that I need this much of memory upfront. I need this much of memory upfront, and whatever allocation that is going to happen in static memory allocation, it is going to happen at compile time. At compile time. That means as soon as you start executing your program, whatever variables that you would have created as part of your C program, let's say you would have created int a, you might have created arrays like this, you might also have created some float variables, you might have created some character arrays too. So depending upon the size of all of these variables that they require, the compiler is actually going to allocate this memory upfront as soon as the program starts its execution. So this will consume 4, this will consume 40, this will consume 8, this will consume 30. So the sum of all these values will actually get allocated to your program. So this is going to happen upfront. That means as soon as your program is compiled. Okay. Now the question is that while your program is under the execution, there might be scenarios where you might need to request for some additional memory. Okay, let me repeat my statement once again. There might be scenarios while working with C programming language where you might require some additional memory, but that requirement is not known while writing the program or before the program. Because if you know that there is a requirement, we will need some extra memory, you would upfront require or request for that memory. So here you have written so much, you can probably write memory allocation for some extra variable, say int extra. Say you can create extra as an array, so you can request these 40 bytes memory upfront at the compile time itself. Why do you need dynamic memory allocation? Dynamic memory allocation is when the program is already under the execution. When the program is already under execution and whatever memory that you had requested for, it is already completed. Now you are asking for more memory. That means it is happening at runtime. The static memory allocation phase has already been over. Whatever variables that you had created as part of your program, they all are fulfilled. Their request is fulfilled. Now you need more memory. And more memory is when the program is already under the execution. So how would you do that? Now you cannot go into your program and can write this. You cannot, touch your program which is under the execution and simultaneously or immediately write int extra. I need this memory as well. Of course, you cannot do that. So what will happen is you will have to request for that memory when the program is under the execution or at the runtime. But the question was that if you already know that this requirement will actually arise at some point of time, why don't you declare it upfront? Why don't you let the memory to be allocated to this extra as well during the static memory allocation phase only, during the compilation phase only? Why not? Again, I would like to touch upon the concept or the criteria of optimization. Optimization means that your program should run as fast as it can and it should consume as less space as it can. That means if your program is taking 100 bytes, you should always think about of decreasing this memory usage of 100 bytes to something less than that. Even if you can do 99, that is going to be an achievement for you. So that is why when there are some things where you are not actually aware whether this condition or whether this scenario will actually arise in the program or not, because this scenario is probably coupled with some specific user inputs. Let's say if the user will enter this specific input, then you will be requiring that extra memory. Okay, let's say you are writing a program which is going to accept some user information, and depending upon the age, you need to ask for some extra information for the user. Let's say if the user is above 18, then you also need to ask for voter ID. You also need to ask for maybe some other things. Like just for an example, say voter ID. If the user is over 18, then you will have to also ask for voter ID. But voter ID is not required when the user is less than 18 age. So in that case, it might be a bad idea. I'm just talking about a very specific use case. This might not be true in the real world scenario, but I'm just trying to give you an example so that you can relate to it. Now, there are, let's say, 10 users, the data for which is going to be entered as part of your program, and 9 of them are below 18, one of them is above 18. Now, if one of them is above 18, if you declare this memory requirement upfront, that means you are asking for 40 bytes. But even if you think about it, you actually only require 4 bytes. Right? So ultimately, you are wasting this 36 bytes of memory usage. When I said that if you can even bring down the memory usage from 100 to 99, that is a big achievement. Think about bringing down your memory usage by 36 bytes. That is going to be a very big achievement for you, right? So in that case, these things are better to be handled during the runtime. That means if it is possible for you to request for some extra memory resources when the program is already under the execution, that would make your life more easier, that would increase or that would make your program more optimized. Your program will require less memory in order to work with or in order to operate. Right? And the memory which is requested in such scenarios, which are already, which are not requested upfront, but which are required during the runtime, this type of memory is known as dynamic memory allocation. The scenario we have already discussed where, let's say you are accepting user data, 10 user data, but when the user is above 18, you need to accept some additional information, say voter ID, and in that case, you will have to dynamically request for that memory. Of course, you can do it upfront as well, but that is going to be memory wastage. So if you want to make your program more optimized, you would do this thing at the runtime. Now, if you're doing it at the runtime, of course, the question arises, the question comes, how? Because so far, the way we have written C program is, we simply use data type. We use data type. Then we choose the variable name. We choose the variable name. If this is an array, we will use subscript, else we will not. This is the type of syntax that we have been using. But now the question is that if we need to request some additional memory, how do we do that? And in order to accomplish those tasks, we are provided with some utility functions, just like the utility functions strlen, strcmp, cpy exist. Some utility function do exist for helping us with dynamic memory allocation. And the two functions that we'll be using for requesting additional memory are going to be malloc and calloc. We can also use realloc, but that is not used much, especially in our scenarios where we are only trying to understand the concept, where we will only use malloc and calloc. There is one more function that will come handy, which is going to be free. Now, you need to understand that when you created or when you requested memory by using a syntax like this memory was allocated at the compile time, right? And this will be destroyed when the program will finish its execution. But when you are requesting for the memory at the runtime. That means when you are requesting for dynamic memory allocation, it becomes important for you to free that memory block whenever you are done with that. Let me tell you a scenario. Let's say the entire memory that is available to our computer system is 100 bytes. I'm just taking an example, right? 100 bytes. The program that you are running, it has already consumed 96 bytes. Just for an example, it has already consumed 96 bytes. Now, at some point, you realize that you need 4 more bytes. So let's say you requested 4 more bytes with the help of one of these two functions. We will talk about the syntax later on. For now, I'm just telling that you requested some additional 4 bytes. Additional 4 bytes since this memory was available, because 96 plus 4, 100 bytes, though you are consuming the entire system memory, which will probably not happen in real case scenarios, but just for the sake of understanding, I am saying that yes, this request will be fulfilled and this 4 bytes of extra memory will be given to you. 96 plus 4, now your program is consuming 100 bytes of memory and the system only has 100 bytes of memory. That means there is no extra memory can be allocated further. Now, after using this 4 bytes memory, you realize, oh, I need 1 byte of more memory. You require 1 byte more memory. But now when you will request for 1 extra byte of memory, the request will be rejected because the system itself does not have those many resources available. How will the system be, or the operating system be able to allocate your program this extra 1 byte? And here the scenario is that the extra 4 bytes that you had requested, you are already done with that. You don't need those 4 bytes anymore. You wanted to store some data in that. You have already stored that. You have used that. You have processed that, and the work for that 4 bytes is over. So the ideal scenario is when you requested for this 4 bytes, fine, the operating system did allocate this memory to your program. But as soon as you are done, it becomes your responsibility. It becomes the programmer's responsibility to free this chunk of memory as and when you are done, or as soon as you are done. Because as and when you will free this memory or you will release this memory, the operating system will again say that it has 4 bytes of free memory. And when you will request for this 1 byte of additional memory, the operating system will be able to fulfill your request because it has 4 bytes of extra memory. But if you will not release that extra memory that you have requested at runtime, then it will become a problem and your program will eventually crash. Because if the memory that you're requesting for is being used for a vital operation and that vital operation would not be performed, your program will ultimately or eventually crash. So that is why it is the programmer's responsibility to release the chunk of memory that he or she has requested dynamically. Are you able to understand the overall picture of dynamic memory allocation?
Yes, sir.
Yes, sir.
All right. Now that you are able to understand this, let's talk about a little bit about syntax. Firstly, I'll tell you about malloc and calloc, the syntax of it. Both of these functions I'm telling you are used for the same purpose. They are used for allocating the memory dynamically or during the runtime. This is what their purpose is. So malloc, the way it works is, it requires you to pass the number of bytes you want to request the additional memory of. So it is requesting, you have to provide number of bytes. And here in calloc, the way it works is, you first have to provide the number of units, and the size of each unit. This is the syntax of calloc. Thus, the syntax is different, but they are going to do the exact same thing, because the way you will be using malloc is, let's say you want to work with 2 more integer values. So the way you would do with malloc is, either you can pass directly 8, because one integer value will require 4 bytes, so you can say 8, or you can also write it like malloc 4 multiply 2. You can write it like this, or you can also write it like malloc size of int multiply. If you are working on a 64-bit architecture, all of these things are actually doing the same thing. 8 means 8 bytes, 4 times 2 is actually 8 bytes, and size of int, which will come out to be 4 bytes on a 64-bit architecture machine, and 4 times 2 will again become 8. The reason we write this size of int is so that our code can become platform independent. Let's say if you are running on a 32-bit architecture machine where the size of int is assumed to be 2 bytes, then if you write this, if you write 4 into 2, then you are actually requesting for 4 bytes of extra memory. You wanted to work with only 2 integers, and one integer is requiring 2 bytes in that particular platform, in that particular architecture. So ultimately, you are requesting for 4 extra bytes again. You are unnecessarily asking for extra memory. So that is why it is a good practice that you specify the data type along with the size of operator. So this code becomes platform independent. You don't need to worry about where your code is actually running, whether it is running on a 32-bit architecture machine or a 64-bit architecture machine. Right? If it is running on a 16-bit or something like that, it will only require 4 bytes. Otherwise, it will require 8 bytes. So this is what the syntax of malloc is. Ultimately, you are passing only one single integer value, which is 8 here. Here also it is ultimately 8, 4 multiplied 2. Size of int multiplied 2, it is also 8. So this is what the syntax of malloc is. But if you talk about calloc, the syntax is a bit different. As you can see, it accepts 2 arguments. Calloc. So first argument is the number of units. If I take the same example, since I wanted the dynamic memory for 2 integer variables to be allocated, I will say that number of units are 2 and the size of each unit is 4. Right? This is one way of using it. The other way of using it would be, can someone tell me? What will be the better way of using it? It is going to be 2, size of int. So you have replaced this 4 with actually the size of operator with the respective data type that you want to work with. So this is how calloc will work. And both of these things, this calloc that you are seeing here and this malloc that you are seeing here, they are going to do the exact same thing for you. They are going to request for 8 bytes of additional memory on a 64-bit architecture machine. But the question is, if they both are doing the exact same thing, why do we need 2 different functions? So of course, I understand the syntax is different, but how does that even matter? If they both are doing the same thing, doesn't really matter if I am passing the inputs in this way or this way, I am getting the same end result. Why I am needing 2 different functions, malloc and calloc? Does anyone know? What's the answer? Does anyone know?
No, sir.
Okay, fine. So the only difference between malloc and calloc is, or the actual difference between the two is, of course, one is the syntax, which is the minor difference. The other difference is that the additional memory that you are requesting for, if you try to access that memory without actually initializing it, what behavior do you expect to happen? Let me repeat my problem statement once again. You requested for some additional memory at the runtime. You didn't initialize, you didn't actually assign some value to that additional memory that you had requested before, and you immediately tried accessing it. What is the behavior that you expect? What value will you get if you try to access it? Yes? You will get garbage value. You are trying to access some variable which is not currently initialized. The same thing will happen if you say int a and you immediately say printf a. What will you get in the output? You will get some garbage value because you have not initialized this value a with anything. So what you will get in turn is a garbage value. The same thing will happen here too. If you have requested for some additional memory at runtime and you have not initialized it, and if you try to access it, all you will get is garbage value. This will happen in case of malloc. This will happen in case of malloc. But if you will try to request for that additional memory at runtime with the help of calloc function, what will it do is, it will by default initialize all the memory blocks with the value of 0. So whenever you will try to access those values or those memory locations without actually initializing them, you won't get a garbage value. Instead, you will get the value 0 because malloc is initializing those explicitly for you. And that is the functional difference between the two, the behavioral difference between malloc and the calloc function. Are you able to understand it?
Yes, sir.
Okay, now given the explanation of both of these two things, what do you think? Which function would you be using the most, malloc or calloc?
Malloc.
Yes, you will probably use malloc more because ultimately when you are requesting for some additional memory, there is a high chance that you will initialize that memory before accessing it. But in that case, don't you think the same thing would have been experienced by many other programmers here? Or what is the merit of using malloc over calloc? Can someone tell me what is the merit of using malloc over calloc? See, if you are getting all the memory blocks automatically initialized to 0, this is a great thing. This is a good thing for you. Maybe not great, maybe a good thing, because by accident, even if you try to access some memory block which is not initialized yet, you will ultimately get the value 0 instead of a garbage value. So maybe some advantage. But this is an advantage of calloc over malloc. Can you think of an advantage of malloc over calloc? We have already seen the advantage of calloc over malloc. Now we want to look at the advantages of using malloc over calloc. Any ideas? Any guesses? All right. So see, try to understand it this way. See, calloc is doing everything that the malloc is doing. In addition to that, it is initializing the requested memory blocks with the value 0. So it is doing some additional thing. Do you all agree with this?
Yes, sir.
So this is an advantage. This is doing some extra thing for you. This is an advantage, but this is also a disadvantage. Disadvantage in terms of optimization if it is not required. Because when the calloc is explicitly trying to initialize those empty memory blocks or the recently requested memory blocks with the value of 0, that means it is performing some extra steps. It is performing some extra steps, or you can say some extra code. And if the code that it is executing, and if it is not required, then you are playing with the optimization. You are making your program a little bit slower because the calloc is doing some extra computations, is doing some extra clock cycles. So it is trying to make your program a little bit slow. In case you don't require the memory blocks to be initialized with the value 0, then you should not use calloc. You should always go with malloc so that your program can run a little bit faster. I won't say a significant difference would be there, but yes, definitely some difference would be there because the calloc will utilize some extra clock cycles in order to initialize all the requested memory blocks with the value 0. So that is the advantage of malloc function over calloc. Right? Your program will run a little bit faster. Oh, do you all understand?
Yes, sir.
Right. Okay. And the last thing that I wanted to discuss is it is free. Okay. What you have done is you have used malloc or you have used calloc in order to request for some dynamic memory. As I told you, this is the primary responsibility of the programmer itself to release the set of memory chunks that he or she had requested dynamically so that the same memory resources can either be made available to some other processes if they require them or to the same program at a later point of time, right? So what will happen is malloc or calloc, whenever you will use them, they will actually return you some pointer. They will return you some pointer. Let's say you are getting them in a pointer, say P. Then whenever you are done with this extra usage or this extra memory that you had requested for, you can call this free function. You can call this free function. And you can provide the pointer which contain the address of the extra memory that you requested for. So what the compiler will do is compiler will release that memory. And ultimately this will become available for other processes to be utilized, or even the same process at a later point of time if needed. Did you understand it?
So please can I repeat?
So the very first thing that you have to remember is it is the primary responsibility of the programmer itself that if you are requesting for some additional memory at runtime, which is actually the dynamic memory that you will do either using malloc or calloc, it becomes very important for the programmer to release that set of memory chunk that you had requested dynamically. And in order to release that memory chunk, why you want to release it? Firstly, you need to understand why should you release it. Again, I would like to take the same example. The system has the 100 bytes of memory available. The program already has consumed 96. You requested for 4 bytes of memory. So 96 plus 4 becomes 100. So the entire system memory is utilized. And after that, you require one more extra byte of memory. But since the program or the system has already hit its limit, 100 bytes, it won't be able to satisfy or fulfill this request. But if you would have released this memory, the operating system would have 4 bytes of extra memory with it when you were requesting for this 1 byte of extra memory. So the operating system would have been in a state to fulfill this incoming request, because it already has this 4 bytes of extra memory and you are only asking for 4. It will be able to satisfy your request. But if you didn't free this memory, this 4 bytes of extra memory won't exist, because the operating system will still think that you are working with this memory and it cannot be allocated to other processes. And in order to release this memory so that it can become available to other processes or to the same process, to the same program at a later point of time, you can free that particular memory chunk that you had requested using malloc or calloc before using free function. Are you getting it now?
Yes, sir.
Okay, all right. So this is pretty much that I wanted to discuss in today's session. I wanted to give you a brief overview of all the important concepts that have been or that have been discussed as part of these 3 weeks, 7, 8, 9. And I think I'm pretty much done with that. So does anyone have any questions with respect to whatever we have discussed today?
No, sir.
Okay. Malloc is faster than calloc. We say dynamic memory. Okay, see, that is actually a different thing when you're talking about e-commerce app. So it is actually a web application. What happens in a web application is a server is running for that. A server is running. That means based on the request that the user is requesting, a server is doing some computations in the backend and is going to return you the result. Whereas in the static block, nothing is happening. Maybe you will need a server, but all the server will do is server will just return the same set of files to every incoming request. The server does not have to process anything. Server does not have to execute any code. It just has to return the same set of files as it is whenever a request comes. So that is actually a different thing.
Okay, sir.
Okay, all right. In case there are no questions, then we can probably end the session here. There will probably be one more revision session that will be happening tomorrow. But anyways, I would like to wish you all the best for your upcoming examination. I hope your efforts will yield a good outcome.
Thank you, sir.
Thank you, sir.
Okay. All right. So thank you for joining with us here in this session today. I wish you all the best. Have a good night and take care.